So then, time for another devlog. Something you will notice in this devlog is there's a big major change to the first level. As you can see now viewing the scene is, I completely changed the first level. The reason for this change was, I had no clue what to do with my original level since I really never had a full idea of it. So I decided to change up the scene right here and right now, and instead go with this. Not sure how hard it is to tell, however, I want to go a little bit more for a sci-fi type of feel to the game. Which is why we have these bright blue lights and a lot of like shiny reflective metal areas, because to give off the feel of a spaceship. Okay, so now that I'm done talking about the changes I've made to the actual map itself, I want to talk about three things. So the first thing I want to talk about are colliders. Inside of Unity, there's many different types of colliders, but so far in this game, we've probably been only using like the capsule collider, box collider, and sphere collider, since these are some basic shapes which allow us to do many different scenes. These collider components are very important to games since without any colliders, everything would either go through each other, or detections of certain objects hitting each other would not be detected. So far for this game, we have used colliders to actually make areas where the player is able to jump onto, jump off of, and walk on. Colliders are very useful and is what allows rigid bodies to actually work as well as they do. However, I'll get into that topic next. This component is actually very important to many of the scripts used within the game. The bullet script is a great example of colliders being used within scripting. The reason for this is due to how it uses a on-collision enter argument which requires something to have both a collider and a rigid body. Although I did forget to mention, colliders also have a helpful option which are called triggers. When trigger is selected for a collider, it causes it so other colliders can pass through it while still acting as a collider. So then let's talk about the other important component used in Unity, the rigid body. The rigid body component is what allows most colliders to have gravity within the game. So looking at the actual rigid body component, we can see we can change the mass, drag, angular drag, the use of gravity, allowing if it's kinetic, the interpolate, the collision detection, and we can also have access to two constraints, which is freeze positions on the X, Y, and Z, and freeze rotation on X, Y, and Z. In this game, we have frozen all the rotation values within the player, and added a freeze position of Z. We did this since the player won't really have to rotate too much in the actual game, and also make sure it doesn't fall over while standing. And we also freeze position Z because the player is going to stay on the Z value. An example of rigid bodies being used within our code can be seen inside of the player controller. From within the actual script, we can see RB equals getComponent rigid body. We are doing this to collect the component of rigid body from the object that has had the script applied to it. So once the actual rigid body has been assigned to the variable RB within the code, we can see we start using it in void apply force. The purpose of this section of code is used to apply forces onto the player, which is what allows the movement. This uses the rigid body since most of the forces are being applied onto it. However, as I've been bringing up examples of scripts, we should probably talk what scripts are. Since scripts are very important, I might as well talk about how they're made. You can make an empty script by going to create C# script within your actual assets folder. Or you can go onto any object in the game that you want to give a script to, click add component, name the actual script, and select new script. So now actually viewing an actual empty script, we can see that it only has a void start and a void empty. These scripts are actually very important since it's what allows most of the functions of a game to actually work. So in a way, these C# scripts that we make are almost like the components built into the actual Unity game engine. However, these are more flexible and we have to make them ourselves. The importance of making your own components is very important since not every single game will always use the same movement. Some people go for different type of movements with different type of feelings. So C# scripts are very important since if you know how to code, you can make any type of movement. Going off of a first-hand experience, I would say making these scripts may look confusing, and probably are, but I have tried a bit on my own and I got my player to move forward. But it's also one of those things where it takes a while to actually learn, and just keeping up with practice is very helpful. So, with all of that out of the way, let's talk about how we actually made the player in the game move. So now viewing the actual player controller fully, we can see we have a few functions, which are void start, void update, fixed update, apply forces, check for ground, get input, and check for wall jump. So then, let's talk about the actual get inputs part of the code. In this code, we have the variables is jumping and move direction. Is jumping will detect if the jump button is held down or pushed down, and the move direction of X detects if A or D are being pressed down but summarized as horizontal. At the bottom of get inputs, we also see if the if input.get key down, key code left shift is true, then shooter.fire will happen. However, that's not important to the movement, and we'll probably get back to this sooner or later. So scrolling a bit up, we can see that this get input scene we just looked over is inside the void update. We do this since the information within the code is something we want to check every single frame of the game. So then, before we talk about applied forces, let's talk about check for ground and check for wall jump. So then, let's look at check for ground first. Inside this function, we can see is grounded equals physics.raycast transform dot position negative vector 3 dot up 1.12 float. So this 1.12 float is the actual size of this physics raycast, and the negative vector 3 dot up is the raycast pointing direction, which is down in this case. If this physics raycast does detect a collision, the is grounded boolean will be returned as true. If not, it will be returned as false. So with that small bit of code out of the way, let's look at check for wall jump. So then, viewing the starting of the function for check for walls, we go directly into an if statement, which is exclamation mark is grounded and input.get button down jump. What this if statement does is, if it checks if the button that's down at the moment is jump, and if is grounded is equals to a false statement, it will go through and do the code within. So going a little bit farther down, we can now see that we're getting back and doing more physics raycasts. So then, looking at the first physics raycast, we can see that it's a raycast that will test whether or not the wall is on the left side. If no wall is detected on the left side, it goes into this if statement if true. And because the wall is on the left side, it will rather instead do the raycast onto the right side. So this way, we can check if the wall is either on our left or on our right. So then, after those two if statements are done, we go into if hit.transforms not equal null, which means it hits something. We then go into this code under it. The is wall jumping boolean would equal true since we have hit a wall. We then bring a new actual variable into this code, which is variable dir x equals 0f, or for float. Now then, we'll go into another if statement, which is if the hit's transform position, or what the object was hit at, if that x value is actually less than the transform position, dir x will equal 1. If this is not true, it will go into the second value, which would be negative 1f. The reason we're doing this is, this tells us if the scene gets onto our left or onto our right. And if one of them isn't true, then the other one is. So once all of this is done, the wall jump direction will have a new vector, which would be dir x, which is like left or right, plus 1 on the y value since we need to go up to do the wall jump, and it will of course stay at 0 on the z-axis. So now is jumping would equal false, and is wall jumping would equal true. So then, now looking actually more into the apply force, we can see it does the check for wall jump and check for ground functions first at the very beginning, since this is very important information to know before doing any actual physics. So then, we have this first if statement, which is jumping and is grounded equals true. If this is true, we'll add force towards the up times the jump height. What this means is the player will now be jumping. However, right after that, it will do another if check statement, which is while jumping. If this is true, it would then be the while jump's direction times the while jump's force, and this will be added as an impulse force mode. And then is while jumping will equal false, and it will return and stop here. Now then, looking under that, we also have the rb.addForce, which is move direction, which would be left or right, times actual speed we have selected, and this will also again be added as an impulse force mode. So now, within this part of the script, we also have these three flow values, which are xDrag, RBY, and RBX. The flow xDrag will be used as a dragged value within RBY and RBX. So now, let's just look at one of the RB ones. Let's look at X for the moment. We can see we have a mass f.clamp. The importance of this actual part of the code is we want to cap off the limit of the flow value. The actual importance of capping off this value is that if we don't, the player could gain too much speed, which can cause problems with the physics detection. So then, going to the last function of the code, we have the private void fixed update, which then does the function applied forces. The reason we do this inside of a fixed update is because we're doing physics calculations, and we do not want to do it frame by frame, but rather by a fixed update instead. The reason we're using the fixed update for all the physics calculations being done is due to how, if someone has too much FPS, they may gain up too much velocity. However, do it by frame and they have lower FPS, then the physics will seem off. So we do a fixed update instead so it matches most frame rates, no matter how high or how low. However, before we actually end this part of it off, let's talk about the actual player controllers in Unity. Within Unity, we have many variables you can mess around with, which are speed, the drag value, the jump height, and the wall jump forces. Each of these values will affect the actual movement of the player, with speed changing how quick it goes, drag value changing the actual drag value, changing the jump height value changes how much force on the Y value is added, and then wall jump force of course changes the wall jump force added. So then, looking more into the game, you could probably see that we have something in front of the player. In my case, this is the weapon model I decided to make. The thing is, how exactly do these enemies know we're actually hitting them with a projectile? Well, let's talk a bit about it. So then, whenever an enemy reacts to taking damage, it's due to how in the projectile script, we have a collision.gameObject.sendMessage take damage. Send message option don't require receiver. The message being take damage is actually very important since inside the house script, we have a public void which is take damage. So whenever a collision happens between a projectile, which has this script that sends a message of take damage, and it hits an enemy that also has a script of house, well, the message sent will cause that function to play, which will then take off 1 hit point off of the enemy. However, once all the hit points reach down 0, the enemy will then be destroyed, causing the enemy to die. So due to the public void function and the send message, we're able to transfer this information between both the enemy and the projectile being shot at the enemy. So then, with that out of the way, let's actually talk about some errors that can happen. Let's just say you as a player somehow find a glitch with the code and you end yourself outside the map. How do we solve this issue? Well, the answer is very simple. We have a rolled floor. So then, the rolled floor script is very important because it makes sure if the player ever gets outside the map, it will reload the scene. Which is why in the code we have if other game object compare tag player to test make sure this is the actual player, it will then load up scene manager and reload scene 0, which is the first level. However, if the player is not detected and rather instead any other game object, like an enemy, it would instead destroy the game object. The reason we're able to do this is since the rolled floor is actually just a box collider at the moment with just a normal trigger. So since after talking a bit about the enemies, I think it's about time we talk about the actual bullet projectiles. Once we actually view the bullet projectiles in game, we can see it's a very simple sphere. For my sphere, I decided to give it a nice bright blue material to match the gun. In my case of the game, I like to exert this blue, very bright color, almost like an energy. So it's like an energy type projectile to me. This projectile being used within the game is actually just a prefab, which I'll get into more later. But this is very important since it allows us to make the bullet with the projectile script already on it. So then looking more into the projectile script, we can see we have a few public floats, which are lifetime and speed, and the actual rigid body public. But that's very important since, without the rigid body, we can't do any collision detection. Alright, so looking at the start code, we of course have the get component rigid body and some rigid body velocity information. We also have the start quarantine, which is the timer used within the code. Another thing we have here is the private void on collision enter. This will be used to send the message of take damage, as I talked about earlier, towards the actual enemy, and then once this is true, it will destroy the game object. However, here we have the I enumerator, and we have destroy after lifetime. We have this just in case, because we do not want the bullet to go on forever within the world, because this can cause issues like killing enemies too early, or just causing other problems within the game, or maybe a few performance drops from too many bullets flying up whenever it's not too viewable. So here we have the yield return after new wait for seconds lifetime. This small bit of code right here will make it so after a while, which should be the lifetime public float, it will destroy the actual game object. So then after talking about prefabs for that last bit, what are prefabs? Prefabs are very simple. When working in Unity, we can add in many shapes and many different models into the game, and we could add components. However, you will notice if you want the same component on one thing every single time something summons, then you probably want to use a prefab instead. In our case for this game, we have the prefab of bullet. Our prefab for the bullet contains a spirit collider, the rigid body, which is common on all spheres. But we also have this special script called projectile, which includes the lifetime, the speed, and the actual rigid body. Because every single time a bullet summons, it has to have these components, we make this into a prefab so that way whenever it's summoned, it will always have these. Overall, most prefabs come in very useful whenever there's one type of model with set components or colors that you want to be repeated over and over again at certain times. If something is only ever used once in the game, like an enemy that has a permanent death that will never respawn, then you do not need to turn to a prefab. However, if it's like an enemy spawner, then you probably want to use a prefab if you're using special enemies. However, actually looking back on a few things, you probably may be wondering how come for the world floor we can actually pass through it, and for all the other grounds and walls inside of our game, we cannot. The reason for this is due to how the rolled floor is actually a trigger, which I did talk about earlier in the video, and this trigger is what allows us, the player, to go through it, because it's no longer just collision, instead it's testing for anything that enters into it, which allows us, the player, to pass through, unlike a normal collider, which acts more like, well, a wall. So then, looking back on the script, I really didn't explain too much about why the code inside Unity can detect, if we're going left or right. So thinking back on the scripts, we had the check for inputs part of the actual player movement, and we can see we actually had the, it would check for the inputs of horizontal. In Unity, horizontal will be translated towards the letters A and D, and I think left and right on arrow keys. The actual values that go into this is actually +1 you hold down D to go right, and -1 whenever you actually go and hold down A. So this causes -1 on the X for A and +1 for D. So then, the actual player is able to jump due to the fact that in the player movement script, we have the input of is jumping equals input dot get button down jump. Whenever this is pressed, the jump word, which in this case is spacebar by default within the Unity engine, but it can be changed, it will make this statement true. So whenever is jumping is true, it actually causes the y-axis of the actual player to have force added by +1, or by the jump height value. So then, looking back more on the script, you may be wondering, Why can the player not jump in the air? How does the actual script know whenever the player is grounded and whenever it's in the air? The actual answer to this is very simple, as I did talk about it earlier within the actual video. Inside the function for check for ground, we have a physics raycast. This physics raycast is very important since it draws a line from underneath the player, and if it detects any collision from that line, the player will know that it's on the actual ground. So whenever it jumps, nothing will be detected under that line, which means the actual it's grounded will come back as false. But once it lands back onto the ground, the player will know it's grounded because of an actual physics ray has detected the actual collision. Without this imaginary line of the physics ray, the player would be able to keep on jumping throughout the air for as long as he really wanted to. However, in this case of the game, we do not really want that, so we run a physics raycast to make sure the player is on the ground. So let's actually talk about another type of jumping, which is double jumps. At the current moment for our game, we only have the player set up to jump once. However, it's easy to modify the code in order to allow the player to jump more than once, hence allowing the player to double jump. So, the code for double jumping is not inside my script at the moment. How will we make it work is the real question. I have a vague idea of how it could work. Most of the scripting has already been done for jumping, so we'll use this as the baseline and instead add something called a variable. So then how exactly will this work? I'm not fully sure, but my main idea is we could probably have a variable which would be the max amount of jumps, then another variable that will be current amount of jumps. So then my idea for this is whenever you the player press the jump button, the amount of current jumps will go up by 1. And then once your amount of current jump actually equals the max amount of jumps that your player can do, it will cause the player to no longer be able to do jumping. This can easily be done within the script by making is jumping equal true, which will then cause the player to not be able to jump again until it is grounded again. So from here, we would also probably want to change the script up a bit more by making it so whenever the player is grounded, it will set back the current jumps back to its original number, which in this case would be 0. So with all that out of the way, I want to talk actually a bit more about my game I'm making. So then, for making this actual game, I want to say I did learn a fair bit more about the actual work that goes behind making the game, and it did actually inspire me to write a bit of personal code I wrote. However, that was more of seeing if I could actually even make a script. I also, of course, learned that whenever it comes to making games, it's not as simple as saying, I want to make a game, because there's lots of work that actually goes behind the scenes into making these. Because, after a while, once you play lots of games, you can just look at them think, they might be hard to make, but they can't be too hard. The reason many people get this saw is because there's many games that are made with high production value, and there's some games where they work with what they have. Which also may cause some people think, this job couldn't be too hard, or it will be easy after a while. As a person who likes to play a good variety of games, I would say it's understandable to have this mindset, but once you really start to try and make a game, you can see the many issues, like trying to be creative enough to make a game that seems enjoyable, or knowing how to make something for the game that you want. For example, like a certain type of movement or camera effects. However, that type of thing does take a while to learn, and it can sometimes be very hard to make, depending on what you're going for. So then that's why for the next few steps of this game, I actually want to go back into probably making a few more 3D models to improve the game. For example, here for the first level, I have these white cubes, which I wanted to turn into crates, or until, a crate-like shape. But because of how much time I actually took making the map all in one day, I just set these up as quick little examples to use as walls and a few platforms. But I do want to change this very quickly. Another thing I want to change is actual coins models. That's mainly due to how I feel like it doesn't match up too much with the environment I'm going for. Even though I could probably just make them blue like everything else, but I want to make it a little bit more special. However, an actual personal step I want to take in this game is maybe learn a bit more about scripting, since I've tried scripting once, and it was mainly just looking at the Unity documentation codes. but I got to learn a bit of it, but it was still hard to understand, which is why I want to learn a bit more about how to code. So far in the game, the only real things I want to see be added to it is probably more projectiles, since only having the small projectile and the big projectile isn't really too good, since there's many different types of projectiles in games, but these are still a little bit too basic. However, talking about adding more projectiles actually leads into my next script I want to see added, which is a way to change the model of the weapon whenever you switch between projectiles. My reason for this is, it would be a bit strange to have all these different projectiles coming out of the same weapon without any change to it. And it's also definitely not an excuse to practice more 3D modeling for me. Another script I think may be fun, but also may be a little bit hard to make, could be dashing. The real reason I want to see dashing added into my game is mainly since it's a movement that the player can do that I really do enjoy in games. The concept of actually dashing in games is interesting since depending on which game you're playing, it can have many different things. It can hurt nearby enemies, it can just allow you to move quicker, or it can even allow you to actually dodge projectiles. However, since we're doing a 2D platformer, it may be not the best option, but I think it can still be a nice addition to it. So far from all of this, there's only been a few more things I really want to learn, which is of course more scripting since it's Unity and that's the most important part of it. Then something I'm probably gonna learn personally is just more 3D model practicing since I want to get a little bit more better at it. I don't ever expect to make high quality models, but making decent to semi decent models is okay with me for now. With all of that really being said, it's finally time to end this devlog. Hopefully by the next one, there may be a second level, and there may be more models added to the game.